Hi everyone, welcome to this next video. So in this one we're looking at sequencing. We're going to talk about basic sequencing, so this arithmetic sequence, and then we're going to talk about geometric sequences and specifically quadratic sequences and how we can work with those. So this first one will be on higher and foundation, and the second one will just be on higher, but I'll explain that as I get to it. So let's look at it straight away. So find the nth term for the following arithmetic sequence. So we've got 8, 13, 18, 23 and 28. So this would be the first part of the questions. This would be part A, and then this second part here would be part B. So the first thing you want to do is you want to find the difference between the terms, okay? So the difference between 8 and 13 is 5. Let's just double check that it's the same for the next one as well. Between 13 and 18 is plus 5. 18 and 23 is plus 5. 23, 28 is plus 5. So this is your difference, okay? Now, what you then need to do is, if we look at the fact that this is my first term, second term, third term, fourth term, and fifth term, what you want to do is you want to go back and find your zero term. So if I then am going that way, now I need to subtract 5. And if I subtract 5 from the 8, I end up with 3. So my zero term, so this is your zero term, is 3. So in order to then get your nth term for an arithmetic sequence, you take the difference, you put that in front of n, and then you put your zero term at the end. So what do I mean by that? So that's your key points. What I mean by that is, my difference here is 5, so we've worked that out. So you put that in front of n, so it becomes 5n, and then whatever your difference, whatever your zero term here, and the zero term is 3, you put that at the end, so it becomes 5n plus 3. Now, key thing to be aware of, this number here is a positive 3, which is why that is a positive 3. If, for example, if I took away from this first term, and it turned this to a negative number, then you put a negative number here. Now, let's just double check that that actually works. So this is how you can always be confident that your answer is correct. Pick any one of these terms here. So let's just choose the fifth term. So I'm saying now n is 5. So that because n represents any number in the sequence, I'm saying I'm using the fifth term. So I just say 5n, which means 5 times 5, because the fifth term is 5, and we've got to multiply it by 5 there, which gives me 25, and then I'm saying plus 3, which does give me 28. So that is correct. Let's double check it one more time. Let's choose the fourth term now. So what I now do is I go 5 times by n, and n now is 4, which is 20, and then add 3 on, gives me 23. So that is the fourth term. So I know that all of that I've just done there is correct, meaning that my answer must be 5n plus 3. So this would be your answer. Okay. Right, let's look at the part B then. Billy says 56 is the 10th term in the sequence because the fifth term is 28. This is a really common style of question. So where the fifth term is 28, a lot of pupils will just think that all you do is double that fifth term and you end up with the 10th term. Now let's just double check that, right? So if we look at the second term is 13. So based on that logic that Billy's saying, if I double the second term, I'd get the fourth term. And if you double 13, you don't get 23, you'd end up with 26. So that logic isn't true. So here's how we can show that it's incorrect. So 56 is the 10th term, right? So now, because we're talking about the 10th term, we go back to this and we say 5 times by n, which is now 10, which is 50, and then we add the 3 on, which gives me 53. So you could say that the 10th term is actually 53, not 56. Okay, so that's how you're showing that Billy is incorrect. Okay, and this maths is your proof, gives you the logic that you need. Okay, so that's your basics of sequencing. If you were given, for example, let's say you were given a sequence that said the nth term of a sequence is 3n minus 2, and it might say write the first 5 terms. Well, all you'd do is you'd go 3 times by 1, because n would become 1 for the first term, which is 3, minus 2, which is 1. So your first term of your sequence would therefore be 1. Your second term, so your second term of the sequence, now you'd do 3 times 2, which is 6, minus 2, which would give you 4. So your second term would be 4. If you were then carrying this on, so the third term, 3 times 3, which is 9, minus 2, which is 7. So your third term would be 7. We'll finish it off here. So the fourth term, so you're now doing 3 times 4, which is 12, and then take away 2, which is 10. So your fourth term would be 10. And then finally 3 times 5, which is 15, and then take away 2, which gives you 13. So your fifth term would be 13. Okay, and you can double check that's correct, because look, that's going up by 3 each time, by 3 each time, by 3 each time. And if I was to go back here and take away 3, I end up with minus 2, which is what I've got there. So I know that that sequence is correct. Okay, so that is your information on arithmetic sequences. So this bit now would only be on higher. So this is what we're looking at. So this only needs to be something you think about if you are on higher. Okay, so I'm going to show you some tricks and tips for this one. And then hopefully if you can remember the process that we go through, it should help you when it comes to the exam. So the first thing to think about is we need to find the difference first of all. So the difference between 12 and 16 is plus 4. The difference between 16 and 22 is plus 6, plus 8, and we're now adding 10. So what you can see compared to the one we've just done, the difference is changing each time. It goes 4, 6, 8, and 10. So what we then need to do is we need to do a second difference. Okay, so this will be called your common difference, because what you can see is it's going up by the same value. So this is your first difference, and this becomes your common difference. Okay, so this column here, this row here is your common difference. Right, what I'm going to do is I'm just going to move this to the side to create a little bit more space. What you now need to do is, in your exam paper or whenever it comes up, just draw a line diagonally back, because that represents everything that we are going to now make. So everything I'm giving here is in the exam, it's in your question. Anything this side of the line we are making up, we're going to use. So what you're going to do is, similar to what we did before, you're going to go backwards. So if I'm adding 2, moving that way, I'm subtracting 2 there, which means that here, this would then move to a plus 2, because 4 minus 2 is 2. And then for the top row, what I'm doing is 12 minus 2, which gives me 10. Okay, now I can see where obviously I've written plus 2 there, but actually because we're going backwards, we're going to have to subtract 2. If I was going this way, I'd be adding 2 to get the 10 to 12. So because we're working backwards, we're just subtracting it. Now this is my 0 column, this is my 0 term. Okay, then what I'm going to do is I'm going to write the letters C, B, A. Quite easy to remember. It's CBA, not ABC. And then we're going to talk about what the format should look like. So this is a quadratic sequence. Now, quadratic should be in the form of an squared plus bn plus c. And those of you that have watched the quadratic formula video or any of the stuff I've done on quadratics, that will be quite familiar with you. So it means that my answer needs to be in that format. I need to have something n squared plus something n plus c. Now here's how you find your values, and this is the key piece of information. If you can remember, these become quite easy to work out. The first thing you need to remember is A is half the common difference. Now remember what we said, the common difference is that bit that stays the same, and in this case my common difference is 2. So you're going to do half of 2, so 2 divided by 2, which is 1. So we're saying A becomes 1. To find B, you take your 0 term of B and you subtract and minus your new A value. So let's just check what that looks like. So my 0 term of B is this one here, it's 2. and you minus your new a. My new a is 1, because that's what I've got here. So I'm doing 2 minus 1, which is just 1. So b is actually also 1 in this case. And then c is very simply, this is the easiest one to do, your 0 term of the sequence. And my 0 term of the sequence is 10. Okay, so now what I've got is a is equal to 1, b is equal to 1, and c is equal to 10. Just be aware, in case there's any negatives in front of those, you need to be aware of. If this sequence goes down, it means that that would become minus 1. And if there was a negative value here, just be aware of putting your negative values in. And I now just substitute these values into the equation up here. So a is 1, so technically 1n squared plus 1n plus 10. But because we want to write that mathematically, n squared plus n plus 10. And that is your answer to the nth term for the sequence. Let's double check ourselves like we did in the previous example. So let's choose the 5th term. So if I check that, I'm saying n is 5, so 5 squared plus 5 plus 10, and it should give me 40. So let's work that out. 5 squared is 25, plus 5 is 30, plus 10 is 40. So I know that works, and if you really wanted to, you could check it on any of the others as well. So now we've got our sequence, our nth term for the sequence. Key thing to remember here is how to find this a, b, and c value. So this bubble here will be something that's worth writing down, making a note on. That will really help you. But a key thing to think about is that formula, n squared plus n plus 10. So what I'm saying is 430 a term in the sequence? Well, if it is, I could say n squared plus n plus 10 equals 430, because it should be in the sequence, right? So there's a couple of ways we can think about this. If we look at that, we know it's a quadratic, so in order to solve a quadratic, let's make it equal 0. So you want to then rearrange this. So n squared plus n plus 10 minus 430 equals 0. If you're not sure on how to solve a quadratic, go back and watch the videos I've done on solving quadratics as well, because that will help you. N squared plus n, and then 10 minus 430 is minus 420. And what we're looking for here is two numbers that add to give me 1 and multiply to give me negative 420. Okay, so you've got to think about what two factor pairs would end up giving you those values. So looking at this, it's not the easiest two factor pairs to think about, but actually if you do a little bit of working out, you can figure out it is 20 and 21 are my two values. So 20 times 21 gives me 420. So they are my factor pairs. So therefore what you do is you say n in both brackets, because we're factorising it to solve it, equals 0. Now we need to make a positive 1. So we're going to say plus 21 and then minus 20. Okay, because 21 minus 20 gives me 1, and 21 times minus 20 gives me minus 420. So we say n plus 21 equals 0, or n minus 20 equals 0. So therefore n is equal to n is equal to negative 21, sorry, or n is equal to 20. Now, because we have a solution, it is a positive solution here, we can say that it is the 20th term. So when you solve it, if you get an integer, which in this case we've got the 20th term, but also you could say that it's the negative 21st term. So if we carried on going backwards here, if we carried that on to negative 21, then you'd end up getting an answer of 430, because remember, when you square a negative number, you'll end up with a positive value. So it would be the minus 21st value and also the 20th term. So we can prove that 430 is in the sequence, because when you factorise and solve it, you end up with an integer. If you were to solve it and you get a non-integer, so you end up with a decimal, it means it is not in the sequence. So it has to give you an integer to be in the sequence. Okay. So last bit to look at here, it then says another sequence has the nth term rule, 2n squared plus 2n plus 1, first 5 terms, Well, very simply, all we're doing is a case of substitution. You should be quite confident on this. So you're substituting in 1. So we're saying 2 times 1 squared plus 2 times 1 plus 1. For the first one, you're doing 2 times 2 squared plus 2 times 2 for the second one plus 1, etc., etc. So if we work this out, so first of all, remember, do your indices first. So 1 squared is 1 times by 2 plus 2 times 1 plus 1. Well, 2 times 1 is 2 plus 2 times 1, which is 2 plus 1, which gives me 5. So my first term in the sequence would be 5. Then we do the same thing here. Again, be careful, do the indices first. 2 squared is 4, times that by 2 plus 2 times 2, which we know is 4 plus 1. So that gives me 8 plus 4 plus 1, which is 13. Carry this on, 2 times 3 squared plus 2 times 3 plus 1. Well, that gives me 9. Times by 2 is 18. 2 times 3 is 6. 18 plus 6 is 24. Plus your 1 is 25. Let's change your colour. Then we're doing 2 times 4 squared plus 2 times 4 plus 1. Well, 4 squared is 16. 2 times 16 is 32. 2 times 4 is 8. Plus 1, 41. And then the last one, let's rub that out. Just got a bit more space. So the last one you're looking for is your fifth term. So we'll go 2 times 5 squared plus 2 times 5 plus 1. That's 25. Remember to do that indice. Times it by 2 is 50. 2 times 5 is 10. Plus 10 plus 1, 61. So that's just a simple case of substitution. Okay, so that's your two key elements of sequences. You've got your basic sequences and arithmetic that goes up by the same amount each time. And then here you've got a geometric sequence, or in this case a quadratic sequence, that goes up by a different amount. And you get to the second value, it's your common difference on the second row. A, B and C values. So as I said, this bit's really important you get your head around. And then to prove that something is in the sequence, if you create a quadratic equation and you can solve it with integers, it is in the sequence. Hope you found that useful. Hope it helped you guys, and I will see you all in the next video.